Hello, and thank you for attending this Hybrid Cloud and AI IBM presentation. My name is Jan Guerin. I'm leading a group called the GSI Lab EMEA, helping our system integrators partners adopt IBM technologies across the whole spectrum of our portfolio. What I will cover in this presentation today is what it means for hybrid cloud and AI to be at the heart of the IBM strategy moving forward. And what I will try to demonstrate is that both hybrid cloud and AI are playing together in order to solve your client business problems. So a while back, a couple of years ago, IBM made a major announcement when Arvind took over the lead of our company about refocusing our purpose towards hybrid cloud and AI technologies and bring those capabilities consistently to the market. And doing that, we did a couple of bold moves, such as creating a separate company, externalizing our managed infrastructure services into what's known now as Kyndryl and has started operating, as well as acquiring Red Hat as a company. And I will come back a bit later on that second point in our presentation. So the headlines were all about IBM refocusing on hybrid cloud and AI. And basically, having been a cloud consultant, I've been worked in cloud for the last 15 years since IBM acquired provisioning software companies to fuel its software portfolio. I've been in various positions around infrastructure, around software, around services in cloud. And basically, I know what hybrid cloud is all about. I've been witnessing also the emergence of AI, but I've not really thought about why hybrid cloud and AI are important together. And so I started to think about that, and I will give you the result of my thinking. And a question I had somehow to start with was a sort of chicken and eggs question, meaning, well, which one came first? Is it hybrid cloud or AI? Well, we'll see how we can answer that question. But that question brought me to go back into time and think about where cloud originated actually. So 15 years ago, started to emerge a number of actors in what we now call the public cloud. And these companies were running different businesses, be it online shopping, be it search engines. And their characteristics is they had massive infrastructure that was unevenly used across the entire year. And what they embarked on is transform that infrastructure to deliver it as a service for external companies. And that's what created the public cloud in the first place. And obviously, after the internet bubble bursted, at that time, innovative companies, startups, were struggling to get investment into infrastructure. So being able to access infrastructure on the fly through the network very, very rapidly, being able to use it, being able to release it and pay for what they've been using. And on the provider side, being able to pool resources together in order to reduce the white space, use provisioning software and metering software to measure what was being used, was clearly a revolution. And so that's how the public cloud space was created. And companies, enterprises seeing that, and enterprising having infrastructure in their premises, they started to look at the same technologies in order to turn those infrastructures into private clouds. And that's how the world of public and private cloud started. But then what we saw a bit later was another use of cloud, meaning that the fact that these public clouds were existing, then they became a new deployment model, meaning that companies who wanted to release technologies in the market, but were not sure of the final target, the real use cases, and were maturing those technologies, they leveraged the cloud to provide those technologies to the end user in a seamless manner. Instead of asking people to buy infrastructure, install their software, they were just providing these as platform as a service or software as a service over the cloud. And so it's the case of many services these days. For example, when IBM is releasing quantum computers, there's no way we will massively sell quantum computers now to the majority of the technology to enterprises. So releasing those through the cloud for exploration, for universities, research centers to tap into quantum and develop the right use cases, the right programs, the right software, the right algorithm to use quantum is the right way. So cloud was that vehicle for innovation. And among the services that benefited from that new delivery model has been artificial intelligence. So AI is part of the services that, as they started to emerge and as they were maturing, were able to be in contact with their clients, with their customers, and were able to find their use cases. So that's one aspect that came to me from the public cloud and AI aspects, is that public cloud enabled the maturation of AI itself. And obviously now, if you go, for example, on IBM Cloud, you have a collection of AI services at hand that you can use on these IBM public cloud, ranging to the variety of AI use cases from human behavior analogies, such as text to speech or speech to text, such as natural language understanding, to chatbot building middleware, to document processing, to model machine learning and modeling and building together algorithms. So all these capabilities are one click of away in a portal to be able to be consumed. So then I remembered what my data architects uh, I was interacting with in the various projects I was on were telling me about AI, is that there's no AI without IA. So that sentence is resonating, and basically what it means is that if you consider the barriers for successful AI transformations to happen, is there are a number of roadblocks that are evidence that you have to tackle before being able to do AI. AI is about taking good decisions. And in order to do that, you have to rely on good data. And you have to rely on data you can access, data you can process. And so basically, companies embarking in AI, they are very quickly entering into the problems because that's not the way necessarily IT systems and various application systems have been designed in the first place. So when it comes to reaching data, that data are usually kept where they are used by business application and sort of silo isolation. So they are difficult to access somehow. On the other hand, the applications themselves, the analytic tools that are used to crunch those data are discrete and difficult to manage. In order to achieve automation and processes of data, you often need workflows, but basically the culture is not about sharing. So that's very difficult to assemble those. So basically, to summarize, what used to be said is that there's no artificial intelligence without information architecture, meaning there's no AI without IA. So there's a lot of work to be done on the data to start with. And that's basically what we are fueling and instrumenting with our Cloud Park for Data capabilities, where you have the ability to design that information architecture, collecting or connecting to data in order to use them, and then organizing the governance around these data, the rights, the roles, and where you would place them, or if you would access them, where they are. And then analyze the value you can get out of these data. And finally, infuse uh, AI algorithm into applications in order to predict, to take better decisions, and to leverage the data that you have. So doing so, our clients were faced with another issue, is that when we speak about data, we are speaking about many things. And there are many types of data. Usually, what companies are trying to do is to concentrate and leverage their crown jewel, the unique data they possess, meaning data around their clients, data around their clients' behaviors. And in most of the cases, these data are kept in a secure environment, very often on premises by these companies. But on the other hand, in order to compare, to take good decisions, you also may have to access public data, data on the internet that are outside of the company's firewall, data on social media, or reference data of any kind. And on the other hand, also, whatever usage you do of processing, you may have data on the move. You may have data that are kept on or captured on sensors at the edge that you don't necessarily want to move all the time because it's timely and costly. So basically, you want to tackle these different types of data. And here we enter a world of what we call hybrid data management. So basically, that's these aspects of handling the data where they are that drove the need for what we now call hybrid cloud, meaning that those data will be processed either on private cloud when they sit on the company premises, for example, or on public cloud because it's where the data are already on the internet, or at the edge because that's where the data are generated and they will be processed right away where they are. So basically, that's the second finding, is that the maturation of AI led, well, calling for hybrid data, called also for hybrid cloud. And that's what drove the need for hybrid cloud. And what we saw with most of our clients who started to tap on our AI services on our cloud, for example, very quickly they realized the value they could get about these services. But very quickly also they turned to us asking to get the same type of services also to work on premises, close to where their critical data were. So there was really the need to spread those data handling applications or middleware everywhere the client needed them. Thus, the value for hybrid cloud. So obviously, over the few 2 or 3 last years, hybrid cloud became a reality. Companies now are looking at deploying or transforming or moving their application onto hybrid cloud environments. And what we've been doing with our own market intelligence group is studying companies that were successful doing so and those that were a bit less successful. And what we realized is that when a company has a sound strategy to handle that hybrid cloud migration project, they have they gain more than twice the efficiency and the return on investment to move to cloud compared to other companies that don't have such a sound strategy. And what is an hybrid cloud strategy? It's basically made of 2 pillars. The first pillar is the identification of the targets they want to work with. Targets of various public clouds, some of their infrastructure. So building those deployment targets for the hybrid cloud. And then being able to handle the complexity of having to tackle with these multiple targets. Because each time you want to use a different cloud provider, you would have a different architecture, you have different services, you have different management services you have to connect to. So basically, that can add very quickly in complexity to work in the hybrid cloud. So IBM decided to tackle that aspects, and basically that's where the move of buying Red Hat, acquiring Red Hat was. And Red Hat is the open source company industrializing company. So it's the leader in taking the open source project results and hardening, testing, packaging them, and supporting them by through their adoption by enterprises. And basically, if you want to tackle the complexity of hybrid cloud, you need a level of standardization. And that's what open source and open standard are bringing to the market. So Red Hat started with Linux as an operating system, an open source operating system, but very quickly they moved across the various IT software tools, especially the framework that were necessary in the distributed computing era in grid and cloud around OpenStack, for example, historically, and more recently around container orchestration with OpenShift that is integrating a number of technologies like Kubernetes in order to orchestrate containers and to integrate a real distributed cloud operating system for the market. And so what IBM did with that acquisition is that we positioned Red Hat OpenShift as the foundation of what we define as an IBM hybrid multi-cloud platform. So this architecture aims at letting our clients choose wherever they want to be in any public clouds, on premises, so they have the full freedom of choosing the underlying layer on where they want to be. And what we are proposing is to lay down a layer of standardization with Red Hat OpenShift in order to abstract the complexity and the heterogeneity of the underlying environment. In order to fuel a strategy for our client that is to build once and to deploy anywhere, and be able to evolve with changes and possibly evolve around those various deployment targets that they have as part of their hybrid multi-cloud portfolio. And obviously, in order to get the best out of hybrid cloud, the platform is one element, but you need also software and middleware in order to fuel your business needs. And that's where IBM embarked in containerizing the full spectrum of its software catalog into what we name cloud packs, which are bundles of or collections of software playing together in the same domain, such as data, integration, automation, security, in order to bring, so first of all, to integrate to the foundation of our platform through the container technologies, and be able to more effectively serve each of the domain use cases they are part of. On top of which, you have end-user applications that are, for example, in the space of supply chain management or asset management, some blockchain aspects, Internet of Things, additional analytics that are coming on top of these Cloud Pak middleware or software layers. And obviously, all of this is to the disposal of companies, system integrators like Sogeti, to be able to deliver services in terms of advisory, implementation, management, solution integration around all these technologies. So with such an hybrid multi-cloud platform, what our clients are able to do, as we said, is to concentrate on building their hybrid multi-cloud applications and reduce the complexity of spreading them around in all the targets they have identified. Because OpenShift is available and very often as a managed service to simplify work of our clients in most of the industry common public clouds. And OpenShift can also be installed on-prem on the server of the client in order to spread that platform layer and simplify the hybrid multi-cloud. We even have a way to project our own IBM cloud through a satellite approach where Red Hat OpenShift service is supported in order to benefit from the managed service of Red Hat OpenShift on IBM cloud wherever the clients wants to deploy it, if it's not available in the cloud they have selected. So basically, this hybrid multi-cloud strategy created an appeal for companies to adopt a number of software solutions solving their business problems of every kind across hybrid multi-cloud deployments. And the fact that hybrid multi-cloud was available allowed those software to intelligently work with underlying data that wherever they were. So infusing automation and AI or AI-based automation in a lot of cases across those various domains, and IBM putting this into its software portfolio allowed us to have and become leader in a number of application or in business use cases for our clients, be it in the process management, in the content management, in the automation services, be it business or IT. So you have on this chart a summary of all the acknowledgement we got from various analysts company around that leadership. So basically that gave us another step in the journey. After public cloud enabled AI maturation and AI code for hybrid cloud, then hybrid cloud availability fueled embedded AI adoption by our client and the embedding of AI into software product by IBM and others to fuel this adoption. But now, if you remember the chart that I showed, having our platform everywhere, it's still a distributed environment. Hybrid cloud is by nature distributed. And today, more than ever, the success of digital transformation and digital businesses depends on the performance availability of their critical business applications and the infrastructure they run on. So the applications are the business, and the business is the application. If a customer-facing application becomes unresponsive, or even if the application simply slows down, there's a risk of losing revenue, of damaging your brand, or the customer experience suffers for sure. So there's a common study by the Aberdeen Group that evaluates that if you have 1 second delay in a page load for a client-facing application, so if the latency, as we say, of the application increases, then there's 7% loss in customer conversion and 15% loss in customer satisfaction. That's enormous. So as we've seen, applications are now running in hybrid multi-cloud environments. And these distributed environments are complex, even though we simplify the spread and the deployment of the applications in terms of standardization layer of our platform. The operational aspects are complex. And so, for example, the allocation of server and network capacity is static and requires IT operator for changes. The demand for applications, however, is dynamic. So, which means that at the point in time, the infrastructure is either over-provisioned, meaning you are spending more than you need, or under-provisioned, meaning your application is performing poorly. So, in fact, it's usually the business critical applications that have the greatest exposure, that are starving, resulting in biggest loss of revenue or impact on the customer experience. Or at the same time, the over-provisioned applications are easily going unnoticed, raising the cost of the IT infrastructure. So we have a new approach to solve this challenge. Rather than deploying static infrastructure and relying on thresholds and alerts with manual intervention, we use the power and AI and automation to assure application performance, meet the compliance requirement, and ensure an exceptional and cost-effective customer experience. So the key is to move from a static allocation model to a dynamic consumption-based model. And in this model, the discovery of your full application stack is automatic and continuous, with real-time performance analysis. Allocation of resources is automatic based on the performance analysis and AI-driven recommendations. So we begin by ingesting all observable metrics across the entire landscape and up and down the full stack, including storage, physical and virtual servers, containers, pods, memory, CPU, network resources. And we normalize and observe those data in a common model to gain a complete and exact picture of how the relationship between the applications and the infrastructure. And we do this in real time. So we then provide insight into the performance criteria. You can understand where your gaps are. So before allocating resources, we check any policies that you may have set to ensure that we stick to them, not breaching security, for example. We then allocate the resources and validate through the observability stack to make sure we are meeting the performance criteria we were aiming for. So basically the goal is here you serve exactly the resource your app needs, no more, no less, ensuring no more, no less, sorry, ensuring application performance and eliminating unnecessary cost and waste. So the solution I've been talking about is a combination of two of the recent acquisitions by IBM, Instanta and Turbonomic, that we've positioned into our cloud platform, Watson AIOps. So addressing the AI-driven operation space. So Instanta gives you the ability to observe what's happening across your application performance as it relates to the infrastructure you are provided and validate after you made your resource decisioning that you actually meet your performance metrics. So it does that by getting all the observability metrics, ingest and normalize them, analyze them, so you can get immediate and exact understanding of the performance and get actionable insight to make sure your application continues to perform. And these insights will be performed by Turbonomic that dynamically allocates resources based on the actual demand. And that can optimize performance, meet compliance, and save costs. So Turbonomic is able to do that by a number of connectors that are available, covering a full spectrum of application to infrastructure stacks. So here on this chart, you have the view of the many integrations that Turbonomic is able to achieve, and you can recognize a number of cloud or virtualization providers or technologies here. So on top of these two pieces of software, as I said before, they have been integrated into the AIOps offering. So this combination helps us to have an application-centric view. So you can automatically ingest and contextualize observability metrics and events for performance with Instanta on the observability side. You can take actions continuously to resource for performance. So that's more of those real-time aspects on your infrastructure and application. And then you can ingest that knowledge also into Watson AIOps in order to continuously predict and maintain compliance and predict for more midterm and long-term actions. So all these three solutions are together leading to a faster IT decision-making, more efficient resource consumption and utilization, and cost optimization of all your components. So I think we've closed the loop, meaning that we've explored all the aspects of how hybrid cloud and AI work together. So on one hand, AI was instrumental in bringing the requirements for hybrid cloud. And hybrid cloud in return fuels AI adoption. But now AI is also helping to tackle the complexity of IBM cloud, hybrid cloud, and some of the operational challenges. So I believe that now hybrid cloud and AI are true mutual catalysts to solve the business problems of your clients. So now coming to the initial questions, the chicken and egg question. Well, which one came first? In reality, does it really matter as long as they fit well together? I don't think so. And we demonstrated that hybrid cloud and AI really fit together for the benefits of your clients. Thank you. Thanks for your attention. And I will be happy now to answer any of your questions. Bye.